This is Earth. This is our home. It is both solid and steadfast, but also fragile and vulnerable. Experts tell us that the Earth's climate is rapidly changing, presenting a real and major threat to our future. But the causes and effects can be hard to comprehend. Introducing Climate Station. See for yourself how much the climate has changed over the last century. Discover what is causing these changes and the effects they're having on the natural world. Find out what the world could be like in the future if we tackle climate change quickly, and what could happen if we don't. We cannot solve a problem without first understanding it. So, let's begin our journey of exploration. Welcome to Climate Station. You are about to see how the weather affects our planet over a complete year. It's the 1st of March, 2019, the beginning of a meteorological spring in the Northern Hemisphere. Let's start the playback. Every 2 seconds marks a day, another complete rotation of the Earth. At this time of year, tropical cyclones form in the southwest Indian Ocean. This one is called Cyclone Idai. It will turn out to be the second deadliest ever recorded in the southern hemisphere. Over 1,000 people across East Africa will lose their lives. This year, the temperature distribution of the Indian Ocean is uneven. The eastern side is unusually cool, and the western side is unusually warm. This warmer water contributes to Cyclone Idai's record strength, and Africa will have increased rainfall throughout the year. On the other side of the ocean, where the water is cooler than normal, there will be drought. Let's jump to May and look at North America. At this time of year, a flow of warm, humid air heading north clashes with another flow of cool, dry air heading south. Where they meet, supercell storms begin to form. These intense thunderstorms can generate narrow, violently rotating columns of air known as tornadoes, which can achieve the highest measured wind speeds on Earth. Sometimes over 400 kilometers per hour. Further north, you can just see the smoke from huge wildfires in Alberta, Canada. Dry, windy conditions are helping them to spread to a much larger area than normal. As the year advances, the point where the sun is directly overhead at midday has been shifting northwards due to the tilt of the planet. It has reached its northernmost position at the Tropic of Cancer. On that imaginary line lies India, and the direct sunlight is contributing to an intense heat wave there. But it's not just near the equator that's affected by high temperatures. Near the Arctic, it is much warmer than usual, and in Siberia, an area the size of Belgium is on fire. Europe is now experiencing a heat wave as well, and hundreds of people will succumb to the record high temperatures in the next few days. The European heat wave in 2022 will be the deadliest weather event worldwide that year. Meanwhile, back in India, monsoon rains arrive. They form every year when a difference in heating over land and ocean causes a change in the wind direction. They're later than usual, but the most intense in 25 years, fueled by the same warm water that's linked to the increased rainfall in Africa. Over in South America, fires in the Amazon rainforest, which have been burning for much of the year, now reach their peak. They started intentionally to clear land for agriculture, but high temperatures have dried out the vegetation, allowing the fires to burn more intensely and spread more quickly. They appear in much greater numbers this year than normal. As summer progresses in the northern hemisphere, the Atlantic Ocean has been warming up. Conditions are now perfect for the formation of tropical cyclones, such as this one, Hurricane Dorian. It's just made landfall in the Bahamas and is about to become the region's worst natural disaster on record. The damage is catastrophic. At least 70,000 people are left homeless, 84 people lose their lives, and over 200 are missing. Dorian begins to fade and tracks up the coast of the eastern United States. Air currents will transfer that heat and moisture all the way to the Arctic Circle. The Arctic is particularly affected by rising temperatures. On this day, the amount of Arctic sea ice is the second lowest since satellite records began in the 1970s. Back in the Atlantic Ocean, not all hurricanes head towards North America. This one, Hurricane Lorenzo, is traveling towards Europe, and it's the most easterly tracking Category 5 hurricane on record. By the time it reaches the cooler waters around the British Isles, much of its strength is gone. But as the climate changes, will that always be the case? On the other side of the planet, another tropical cyclone called Typhoon Hagibis is also traveling further than usual. As it hits Japan in time for the Rugby World Cup, it is one of the strongest typhoons on record and will become one of the costliest. Further south, Australia has been experiencing months of drought. It is on the cooler eastern side of the Indian Ocean, where rainfall is reduced. Record high air temperatures have made things even worse. Bushfires are already widespread throughout Australia and now in December reach their peak. The fires are having a major impact on the area's ecology. Billions of animals have lost their lives and many areas will take years to recover. Today, on the other side of the world, a Boeing 747 makes a record-breaking transatlantic flight, New York to London, in just 4 hours, 56 minutes. This incredible feat has been helped by a strong jet stream, acting as a powerful tailwind. This high-level current of air is far stronger than usual and is also sending a conveyor belt of storms towards Europe. They hit, one after the other, making it the wettest February on record in the British Isles. That brings us to the end of our eventful year of weather for planet Earth. Another year of extremes affected by rising temperatures. 2019 was the second warmest year on record, and 2020 will go on to be even warmer. Our atmosphere is always on the move. It's constantly flowing from one place to another. Across the planet, continuous cycles of rising and sinking columns of air help to create our weather and define the type of climate in each part of the world. But what causes these air currents? They fundamentally rely on the land and ocean that's near the equator, receiving more direct sunlight and becoming warmer than places further away. Hot air rises, and this helps lift water vapor evaporating from oceans into the atmosphere. As it cools, the water vapor condenses to form clouds. These can grow to become showers or thunderstorms, which can be seen on our satellite video as a near-continuous line of cloud encircling the Earth near the equator. They form when northeast trade winds from the northern hemisphere meet southeast trade winds from the southern hemisphere. As the Earth orbits the Sun through the year, the pole that's tilted towards the Sun alternates, in turn warming one hemisphere more than the other. This creates our seasons and shifts the line of showers and thunderstorms north and south, changing the air currents to help generate seasonal monsoons and tropical cyclones. High at the top of the atmosphere, the cooler air heads away from the equator north and south, where eventually it sinks back down to Earth. This sinking air leads to much drier and calmer weather in these zones, and this is where the deserts form. The air then heads back to the equator to complete the circulation. Air current circulations don't just exist here, but in every location, driving weather systems across the planet, all part of a continuous global circulation. As the Earth rotates, air within the atmosphere is deflected east to west by what's called the Coriolis force. This is crucial for driving the easterly trade winds near the equator and affects the paths of monsoons and tropical storms. The Earth's rotation also plays a crucial role in driving fast-moving ribbons of air high up in the atmosphere called jet streams. The temperature contrast between the warm and cool zones helps to give them their strength. Jet streams act as conveyor belts, carrying weather systems around the planet. Sometimes, factors such as a reduction in the temperature difference between the air masses can weaken the jet stream, causing its shape to buckle and stall, becoming stuck in one place. Regions can then experience the same weather for long periods of time. This causes rainfall to accumulate, leading to flooding or prolonged dry spells, generating drought. It's likely that as the planet warms, the nature of jet streams will change, which could have dramatic impacts on local weather and climate. These changes could also potentially lead to extreme floods and droughts happening more often in the future. Jet stream behavior is an important area of current climate research. As the atmosphere and oceans continue to warm, the behavior of other air currents is likely to change too, which could have a dramatic effect on our future weather. Our atmosphere is all... Ocean currents form a giant circulation system around the planet, transferring heat from the equator to the poles. The Gulf Stream is one of the largest and fastest. It starts when winds near the equator drive surface water northwest to the Gulf of Mexico, where it dramatically heats up. This warm water is then pulled across the Atlantic towards Europe by westerly winds, where it releases an enormous amount of heat and moisture into the colder atmosphere. The freezing air in the North Atlantic cools the water, and as ice forms, cold, salty, dense water is left behind. This is so heavy, it sinks to several kilometers below the surface in the largest undersea waterfall in the world. This helps to drive global ocean circulation, drawing surface waters from the south. In turn, this increases the Gulf Stream flow, returning cold water deep under the surface to the south to complete the circuit. Without the Gulf Stream, the temperature in Europe would be at least 5 to 10 degrees Celsius lower, much closer to many regions at the same latitude that are far colder. Climate models suggest that as the climate warms, the water in high latitudes will become warmer and less salty, leading to less sinking and a weakening of the circulation. Some studies have suggested that this slowdown could happen abruptly, with serious impacts on regional climate and weather around the world. Every year, the seasons bring regular changes to weather patterns across the planet, but there are other naturally occurring patterns that, whilst not as regular, can still have major impacts on people's lives. They can occur over periods of time, ranging from months to decades. Climate Station's weather year coincided with one of these, a fluctuation in sea surface temperatures called the Indian Ocean Dipole, and that happened to be one of the strongest on record. The Western Indian Ocean became much warmer than usual. The extra evaporation caused extreme rainfall in that area. This led to flooding in East Africa that affected nearly 3 million people. Meanwhile, the waters on the eastern side dramatically cooled, causing parts of Australia to become drier and warmer than usual, exacerbating devastating bushfires. This behaviour can sometimes reverse too, often with flooding in Australia and Indonesia and drought in Africa. Another fluctuation has an even greater effect than the Indian Ocean Dipole. In fact, it can be strong enough to affect the temperature of the entire planet. It's called the El Niño Southern Oscillation, or ENSO for short. This time, it's the surface waters of the tropical Eastern Pacific Ocean that become warm, which can have a major impact on marine life. In 1998, El Niño caused the first recorded global coral bleaching event. When the behavior is reversed, referred to as La Niña, there can be strong cold outbreaks in North America, flooding in Australia, and increased hurricane activity in the Atlantic. In the middle of the last century, few people were interested in climate change. Levels of greenhouse gases in the atmosphere were unknown. Temperatures were being recorded, but no one was assembling them to make an accurate global picture. At this time, a young researcher called Charles Keeling was working out a way to measure the level of carbon dioxide in the atmosphere. He found concrete proof that as the level went up and down, Have you ever wondered if climate change is affecting where you live? In the observations section of Climate Station, you can find out. You can select a location close to your home on the globe and look up all the temperature data. Let's say we wanted to look up the temperature for this location. We can select it on the globe, pick a recent year, and see the average temperatures for every month. But how does that differ from the temperatures in the past? We need something to compare against. We use what's called a reference climate. This is the average temperature over a 30-year period of time. We could choose any 30-year period as our reference, but Climate Station uses 1961 to 1990, a period often used by climate researchers that lies within the middle years of our dataset. On the globe, we can represent areas cooler than this climate with blue pins and warmer areas with red pins. The longer the pins are, the bigger the change is. For our chosen location, we can now plot a graph showing how temperatures differed from the reference climate over the years. But now let's compare it with what's been happening inside the Arctic Circle. In this part of the world, the change has been dramatic, particularly in recent years. But we can go one step further. We can compare what's been happening to the warmest summer months and the coolest winter months for each year. Let's select the warmest months. This graph suggests that the temperatures in summer haven't been rising quite as dramatically. Now let's have a look at the coolest months. The change is far more noticeable, indicating that not only are the overall temperatures rising, but the coolest months are getting warmer here more than the warmest months. On the globe so far, we've only been able to look at 1 year at a time. But if we take a 10-year average, we get a much better idea of the overall trend. Here are the 10 years from 1901 to 1910. Now let's jump to the last 10 years. Switching between the two, we can really see how much the climate has changed over the last 120 years, particularly in the Arctic regions.